Alright, in this video we're going to talk about equivalent proper fractions. So if I'm given any proper fraction, I can find an equivalent proper fraction for it. So what does that mean? Well, I'll explain it in pictures. Here I'm claiming that 4 over 8, 2 over 4, and 1/2 are equivalent. So let's look at the pictures to see what we mean by that. 4 over 8. Now if I were to not think about how I've been grouping them, we can see that I have 8 circles colored in and then 16 circles in total. And that's the same thing for here. I've got 8 pieces colored in and 16 in total. 8 pieces colored in, but 16 pieces in total. Now, it's just the way I group them that are different. We can agree that how many I have in total and how many that's colored in are the same across for 4 over 8, 2 over 4 and 1/2. It's just the way I group them that are different. So here I have 4 groups of 8. So I group these into pairs to get 4 that are colored in, and then 8 groups in total. Here I have 2 groups of 4. So I have 4 groups in total, but I have 2 that are colored in. And then lastly, for 1/2, I have 2 groups in total, but only one of the groups are colored in. So all of these are equivalent. It's just the way I group them that are different. So how do we do this? By using numbers and not really drawing all the time. Okay, well let's look at 3 over 5. I can represent 3 over 5 by an infinitely many number of equivalent fractions. I can times it by 2, by 3, by 4, by 5, and I can get equivalent fraction for it. In this case, let's just times it by 3. So if I times this fraction by 3, I have to do it to the numerator, the top number, and I have to times it by the bottom number, the denominator. So what this looks like to find equivalent fraction, be 3 times 3 at the top, and then 5 times 3 at the bottom. Okay? And if I do the multiplication for that, 3 times 3 is 9. And then 3 times 5 is 15. So 3 over 5 is equivalent to 9 over 5. 15, sorry. So 3 over 5 is equivalent to 9 over 15. And there we have it. That's for our first example. So this is by timesing. We can also divide as well to find equivalent fraction. So in this case, we're going to divide by 4. And this will give us a fraction in its lowest terms if I do that. So let's see what happens. So if I do this, I have to divide it by the top. So 12 divided by 4. And the bottom, 32 divided by 4. Okay, and let's do the division for this. 12 divided by 4 is 3, because 4 times 3 is 12. Okay, and then same for the bottom. 32 divided by 4, that would be 8, because 8 times 4 is 32. So we have 12 over 32 is equivalent to 3 over 8. Okay, well that's all fine and dandy, but I'm not always given what to times by or what to divide by. So what we're going to learn about now is what is a greatest common factor. That's GCF, greatest common factor. So what that is a factor, a number, that is the largest number that evenly divides with the top number and the bottom number. Okay, so for this one, we have to find the greatest common factor. So a number, the greatest number that equally divides 3 and 9. So I need to divide this by some factor for 3 and 9. Okay, so the largest one, let's think about it. Well, I can't divide this by 2 because I can't do 3 divided by 2. But can I do 3? Well, let's see. I can do 3 divided by 3. I can do 9 divided by 3. And we'll know that this is the greatest one because if I go any higher than that, if I go to 4, well then that's not going to work out. 3 divided by 4, that will give me a proper fraction. So we know that it has to be 3 or less, or less wouldn't work. So 3 divided by 3, and then 9 divided by 3. So to do top and bottom. So 3 divided by 3 is 1. And 9 divided by 3 is 3. So we have 3 over 9 is equal to 1 over 3. Those are equivalent fractions, and this is actually the lowest terms. Okay, one more example. We got 18 over 24. I have to find the greatest common factor of this. Okay, so yes, I could divide this by 2 and that by 2, but that's not the greatest one. I can actually do this by 6, and that will give me my greatest one. Because 18 divided by 6 can be done, and that's 3. And then 24 divided by 6 is 4. So we got 18 over 24 is the same thing as 3 over 4. So you're probably thinking, how did you know it was 6? Well, you know what? We could actually do it by 2 as well without using the greatest common factor, but it's just going to take us a lot longer. So if I were to use 2, because the top number and the bottom number is even, if I were to do it by 2, I would have to do it several times. So 18 divided by 2 is 9. And 24 divided by 2 is 12. Okay, so 18 over 24 and 9 over 12 are equivalent. But this is not in lowest terms, so we have to divide it again. Okay, well they're not both even anymore, so I can't do 2, because I can't do 9 divided by 2. So the next number I can think of is maybe 3. I can do 9 divided by 3. I can do 12 divided by 3. So let's do that. Divided by 3. Okay, so 9 divided by 3 gives me 3. And 12 divided by 3 gives me 4. Oh look, they're the same. So yes, I could not always have to use the greatest common factor, but look, I had to do extra steps. And if these numbers were larger, I would have to do even more steps. Versus here, if I find the greatest common factor, I only need to do it once. So that's a lot shorter. And that is our lesson on equivalent proper fractions.